Hello, welcome all. I am Saranya from Hindustan Institute of Technology, Information Technology Department. Today, we are going to see about network security. In network security, we are going to see a topic on cryptography. Okay, what is cryptography, basics of cryptography, and what are all the types of cryptography we are going to see. Okay, first, what is cryptography? Cryptography, it is a science of using mathematical algorithms to transfer data into unreadable ciphertext, ensuring security communication across the networks. It provides core security services such as confidentiality, integrity, authentication, and non-repudiation to protect the data from unauthorized access or modification during the transmission. So, it is essential for securing internet traffic, electronic banking, and data storages, etc. Okay, here some important components that we need to learn before entering into cryptography. First, what is plain text and what is the ciphertext? Plain text, it is the original message, while ciphertext is the encrypted unreadable version. Next one, encryption. Encryption, which means we are going to convert plain text to the ciphertext, and decryption, which means ciphertext to the plain text using keys. Okay, first one, symmetric encryption. It uses the same secret key for both encryption and decryption, while asymmetric encryption means it uses a public key for encryption and private key for decryption. Okay, next one is hashing. It creates a unique fixed size digital fingerprint of data to ensure integrity. Next, one little component we need to know is digital signature. It is a mechanism to verify sender's identity and ensure data that has not been tampered with. Right? Just now we are going inside the cryptographic topics. Okay, what is cryptography? We are going to convert the plain text into the ciphertext. Okay, okay, which means encryption. And back to the receiver side, we are going to convert the ciphertext to the plain text, which is the process known as decryption. So, the process of doing encryption and decryption is known as the cryptography. Okay, some features of cryptography are confidentiality. Information can only be accessed by the person for whom it is intended. No other person can access it. Next one is non-repudiation. The creator or sender of the information cannot deny his intention to send the information at a later stage. Next one is integrity. Information cannot be modified in storage or transmission between the sender or receiver side. Next one is adaptability. Cryptography evolves to stay ahead of security threats and technological advancements. Okay, next one is interoperability. Cryptography allows secure communication between different systems and platforms. And last one is authentication that verifies that the sender and receiver whom they claim to be. Okay, that identifies the sender and receiver are confirmed. Who is sending the message and who is receiving the message. Next one, working. Okay, how cryptography works. Cryptography is used to convert plain text into ciphertext and back ciphertext into the plain text. See here, hello, it is a plain text. While using the encryption key, we are going to convert a plain text into the ciphertext, which is an unreadable format. This process is known as encryption. And back, we are going to do decryption on the receiver side, which means ciphertext is converted to the plain text. Okay, that is unreadable form is converted back to the this same hello which the sender has sent. Okay, next one. Okay, the processes the plain text is created. Algorithms are used to which algorithm we are going to use it. Then a key is applied. Okay, encryption occurs, decryption occurs, and at last the receiver receives the message without any intervention. Okay, some types of cryptography are symmetric key cryptography, asymmetric key cryptography, and hash functions. In that, we are going to see symmetric key cryptography. What is a symmetric key cryptography? It is also known as secret key encryption. It uses a single shared secret key for both encrypting and decrypting the data. It offers high speed, efficient security for bulk data transfer in network communication. Widely, it is used with security relying on keeping the shared key confidential. Okay, symmetric key is faster and simpler, and data are and some most popular symmetric key systems are data encryption system and advanced encryption system, right? Okay, next one example of data encryption standards. Okay, DES, which is data encryption standard. Data encryption standard. It is a symmetric key block cipher algorithm developed in 1970s by IBM and adapted in 1977 by NIST to secure digital data. It processes 64-bit blocks of plain text using 56-bit key through 16 rounds of substitution and transposition. Okay. Due to its short key length, DES is considered insecure and has been replaced by AES. Some core characteristics of DES are symmetric algorithm, the same key is used, block cipher, data is encrypted, key size, the input key is 64-bit, but only 56 bits are used for encryption, and rounds. There are 16, perform 16 rounds of complex mathematical operations, substitution and transposition to generate the ciphertext. So it is a diagram for data encryption standard where 64-bit plain text is given as input, and we will be having 16 rounds to perform mathematical operations, substitution and transposition. Okay, we will be getting a 56-bit ciphertext, and which will be used for encryption. Okay, every 8-bit is discarded, making the effective key length of 56 bits. Okay, next one is advanced encryption standard, which is a symmetric key block cipher algorithm adapted by NST in 2001 to replace the DES. It operates on 128-bit data blocks using 128, 192 or 256-bit keys, ensuring high security efficiency across hardware and software. AES is widely used for securing network communication, data at rest, and financial transactions. Here, in data in AES, a symmetric key, which is both sender and receiver, use the same secret key to encrypt and decrypt the data. Block cipher. AES processes data in size fixed size blocks of 128 bit, okay, 128 bits, arranging them in 4 into 4 columns, order matrix known as the state. Structure. It uses a substitution permutation network involving multiple rounds of processing, 10 rounds for 128-bit keys, 12 rounds for 192-bit keys, and 14 rounds for 256-bit keys. Right? Here, each round consists of 4 subprocessors: substitution, permutation, mix columns, and add round key. Okay. Next one, hash function. Hash function, it is a mathematical algorithm that maps input data of any size to a fixed length or string of characters, which is as fingerprint or digest anything. It is a one-way process designed to be secure and nearly impossible to reverse, ensuring data integrity by producing a completely different hash if the input changes slightly. Fixed output length. Regarding of the input size, the hash length is consistent. Example 256 bits or 512 bits. It is a one-way function. It is computationally infeasible to reverse the function and find the original input from the hash. It is collision resistance. That is highly unlikely that take two different input will produce the same output hash. Deterministic. The same input will always produce the same hash. Here there are two types of algorithm. SHA-1. First we will see SHA-1, which stands for Secure Hash Algorithm 1, that produces 160-bit, which is a 20-byte hash value, usually displayed as a 40-character hexadecimal number. It is designed by NSA and published in 1995. It was once widely used for data integrity, and it is now considered little bit insecure due to collision vulnerabilities, and it has been replaced by standard SHA algorithms, which is SHA-256. The SHA-256, which is a secure hash algorithm 256-bit, is a widely used cryptographic hash function that generates a unique fixed size 256-bit signature for any input data. It is a part of SHA-2 family designed by NSA and renowned for high security collision resistance. Some key features are fixed output size, deterministic, irreversible, collision resistant, and avalanche effect, which means a tiny change in the input results in drastically different hash. Some uses of this algorithm are cryptocurrencies, data integrity, password hashing, security protocols, etc. Next one is MD5. MD5, which is a message digest algorithm 5, is widely used cryptographic hash function that produces a 128-bit hash value, usually represented as a 32-character hexadecimal number. While once standard for security, it is now primarily used for non-cryptographic checksums to verify data integrity due to known vulnerabilities. Thank you. Thank you for watching this.